Hello, let's look at a hands-on demo session. We'll be creating a real-time chat application using socket.io. So the major sections of the chat application would be like this. So we will install Babel packages so that the application can support ES6 syntax. Babel would transpile the ES6 syntax to ES5 syntax. We will create a Start.js file, install all the required packages, the socket.io and the express packages. We'll start the server, create the HTML form. The forms would be used to basic forms for chatting or sending messages. We will connect the application in HTML file, so write some JavaScript code so that our HTML file can send messages, receive messages which are being sent and received using socket.io. Configure socket.io on both client and server side. So socket.io library, again, since it's a chat application, so it has to be present on both client and the server. Configure the HTML page to emit the message. Emit message meaning send the message, and check the working of the application. So we will be creating the chat application using ES6 template. So let us first configure Babel environment. So let's initialize a npm application and install all the required Babel modules: Babel core, Babel preset environment, Babel register, and Babel polyfill. Let's open that directory in Visual Studio Code. Let's open the terminal. Let's start with installing the Babel packages. I'll install them one by one. There are times when you try to install all of them together, you might face some errors. It might happen. To be on safer side, I am installing them one by one. So that is Babel core first, then Babel preset environment, Babel register, and Babel polyfill. Babel preset environment, Babel register, and Babel polyfill. Also, when you're installing packages, so the famous packages that you use that we're showing here, the Babel packages, Express, Socket.io, the famous packages usually don't have any problem. They are maintained by many developers and sometimes even many companies. But there are many packages which might be developed by small developers like you and me, individuals. They might not be maintaining it properly, or the code might not be that accurate, or might be having some other problems. So a new feature in the recent times that I've seen in npm packages, once you install it, npm also tells you the number of vulnerabilities found in the package. So let's say if you are using package that is not very popular, you see it has many vulnerabilities, try and don't use that. Try to find a better, safer package or more popular package that you can use in your application. So we'll create the .babelrc file and put in this code. So we installed the packages, we created the babelrc file. Now in start.js, we'll import the Babel register. So, and then we'll import the app.js, and then export it. So basically in start.js, what we are saying is basically the whole app has to use Babel, or Babel would transpile the whole app when we run it or when we create a build. So let's do this for start.js. Let's indent it a little bit. And always indent your code properly. That's a good practice. It's also good for other people in your team. So this line, Babel register, compiles file when loaded, and presets contains set of plugins to convert ES6 features to equivalent ES5. So Babel preset environment basically has, for example, arrow functions, need to be converted into the normal function where you write the function keyword. So that's one example of where the ES6 syntax is converted to ES5. There can be the object destructuring where you use the 3 dots, so that needs to be transpiled. So there has to be equivalent syntax for that. So in that case, there is no equivalent syntax. I mean, for the arrow functions, we have the normal functions, so you can directly replace that syntax. But in object destructuring, we don't have equivalent syntax for that, so there has to be some code to be able to do that. There are a lot of ES6 features which are not there in ES5, so there has to be code, which kind of a fallback code that would actually run that feature in ES5 as well. And we start the application code in app.js. Now let's go ahead and install the Express and socket.io as well. Okay, install Express. Let me just look at the name of the npm module. Is it socket.io or socket.io? Yeah, socket.io. Now In the app.js, so we will import Express and import socket.io and basically start our server. Let's go ahead and do that. IO object gives us the access to socket.io library, so we can use the IO object to do the socket.io stuff that we want to do in our application. And here we are configuring the port and make server listen to the port. So we've also mentioned the port number. That's, so for us it will be 9900. If it's set in the environment variable, it will take that one. Now in the public directory we will create a simple index.html. In the index.html, so this will be user facing. We'll import the socket.io client side library, so we can directly use it from the socket.io's website. Also we will use jQuery for basic stuff, the usual stuff, setting values and events and stuff. We'll configure a button nickname. I used to set the user, so right now for now we are like putting a simple text box and a button over here that will set the nickname. So like username, like who is chatting, and a chat box and a button to send the chat message. Let's do that. Before we create the public directory and put in the index.html file, let's set the Express to use the public directory as a static directory. So whatever is in the public directory is served statically, nothing is processed on the server side. Let's create the index.html file. Now create the body, copying the whole HTML that we have. So this is basically bootstrap syntax. So let me go ahead and copy the bootstrap CSS and JS as well. So we have loaded jQuery before the bootstrap JS. You can even load jQuery and the bootstrap JavaScript at the end of the body tag, but it's okay for demo purposes. Also, please load jQuery before the bootstrap JS. Version 3.4, yeah, any version above 3 these days is good. It's latest. Don't use the old versions, the 1.8 or 2, unless you want to support really old browsers. So we have the bootstrap library from bootstrap CDN. It's good to use that CDN unless you have a really fast server. So we have a simple page setup. Mainly we need to concentrate on this form. Form has the text box to set the nickname, which we just talked about, and a send chat message area. Now moving ahead, so in the app.js file, so we have set the public directory, told Express to use the public directory as statically served directory. So here one thing you need to understand, socket. So with Express we create our HTTP server to do all the HTTP stuff, serving the HTML, CSS, JavaScript file. Also Node will do the any Node.js processing on the server side, which needs to be done. But when you're working on something like socket.io or let's say even WebSockets, there is a separate socket server. So here we have a separate socket.io server. So there will be actually two servers running. One will be the HTTP server, and another will be the chat server or the socket server or the socket.io server to be exact in this case. So we'll have to include this line in our app.js. So we've done this in just one line. What you could do is like this also, it's up to you. So this is like the basic form that we talked about, the place to set the nickname and the area where you send the chat message, the send chat message button. Now let's start with the socket.io stuff. So first on the server side, so we already started the socket.io server. Now handle the socket traffic, the io.sockets.on connection. Set the nickname property of a given client. Sets IO object to listen to each connection to your application. So what happens is, so we have one server, the socket.io server. Now there can be n number of people chatting. Let's say there are 3. Each one of them opens the browser and initiates a chat. So let's say user 1 opens the browser, our server is running, types in the nickname and some message and clicks send. So there will be a socket.io code on the browser also, which will send a message to the server using the socket.io library, and then this callback will be fired saying, hey, we have a new connection. And on the server side we will set a nickname. This can be nickname or username, anything, but in our case we are using nickname. So this will basically handle the incoming socket traffic and listen for new connections. So relay chat data to all clients. So what we are building is a simple chat room. So in a chat room, as you know, one person sending a message will be received by all the users in that chat room. So socket.onChat. So these dot on, consider them similar to events that you've already used in JavaScript. And those events have a callback. So when a chat is received, the callback is called. We get the nickname of that person. So if we don't have the nickname, if there is an error or something like that, we set the nickname to anonymous, like, hey, we don't know who the user is, in case something like that happens. And then we using emit is something like broadcast. You just broadcast a message and that will be received by all the users in the same socket connection or in the same chat room. So we will create a payload object, set the message property and the nickname property. So when user 1 sends a message, the message is received by the user, received by the server over here. We will take the message, take that person's nickname, whoever is sending that message, and then broadcast it to all the other users. So sets your backend application to display user message on the screen. So everybody in this chat room will receive this payload. And here we are writing the client side code. So this is in the browser, the socket.io code in the browser. So first we create the socket object using io.connect. So once you have the socket.io library imported, so similar to jQuery, when you're importing jQuery, you have either the jQuery with J small and Q capital. You either have the jQuery or the dollar object available for you globally to work on it. Similarly, for socket.io, you will have the IO object. So you create the socket object using io.connect. And similar to the server side code, here we have socket.onChat, and nick was the nickname button. So when you click on that, we set the nickname. So we emit our nickname. This will again go to the server and get registered. When you're sending a chat message, so this was the chat button, #chat, ID chat. So when the chat button is clicked, we take the text from the chat text, the box where you write the chat, and you emit the chat. So this will be received on the server where we wrote socket.onChat. So let's go ahead and implement this. So where were we? We've installed socket.io, started the server. We have a basic HTML form. We started listening to socket.io. Okay, we need to implement from this point. Now we have an idea of what we want to do. Let's start. So we've created an array of users. We will keep a list of all the users that have connected to this socket.io server. We have the io.on connection. So whenever we have a connection, this callback is called. Let me import that socket. We receive this socket object from the callback. Okay. So for the new connection, we have socket.on connect. We get the new connection. We'll be able to see these console log messages over here in our terminal. Typically, in most of the cases, when a user who is already connected in the chat room, when the browser closes, automatically the socket connection closes. And that's when the disconnect event is called and we get the callback. We get to do our stuff. We can remove the user from our list, or maybe let's say we have a database where we maintain a list of users. You can do that, or maybe emit a message to all other users saying, hey, this guy left the chat room, things like that. So we have the nick event over here where we set the nickname. Also we push that user into our users list. Again, every place we are doing console log for debugging. So if you can see, we have the emit in mostly all of the events. So whenever a user is disconnected, we emit so that all the users know that, hey, this guy left the chat room. Whenever the nickname is set, so we have a new user and the nickname is set, we emit the new user. So all the users get the updated user list. And whenever a chat is received, we emit that chat so that it's sent to all the users. So we already did this io.sockets.on connection. We set the nickname, chat. Now on the index.html side, we need to write the browser side code of socket.io on the index.html. Okay, so we have the socket object using the global IO object. Similar to the server, we have the on chat, so the chat event, the user list event. Here we are setting the click events. So whenever a nickname is set or a chat is sent, so on the client side, the socket.on a event name means something that is being received from the server. Whatever we are emitting the user list, we are emitting the chat. So if you look at the emit functions, we are emitting mainly two things, either the user list or the chat. So that is received on the browser side using socket.on. So whenever the user list is updated, maybe on disconnect or a new user is connected and we get the new nickname, we emit the user list and we receive it over here like this. Or when the server emits a chat, we get the chat over here like this. And then we will update the text area that we have with the chat messages, add a new line. This is what the user would be taking the action. So setting the nickname, nick.onClick, and the user would emit the nickname, which would be received by the server over here, socket.onNick. So it's very simple. You emit from the server. On the browser side, you have socket.on to catch that event. Similarly, when you can emit from the browser side, that would be received on the server side using socket.on. So in a way, it's pretty simple to understand. So we emit the nickname when it is set, and this we are just keeping a flag for our small logic. So if nickname is set, we can just hide the button. So the user who's already in the chat room can't set his nickname again. So a simple logic, and the code to send the chat to the server, sending a object with message property, and then making the chat box value empty. So what next? So let's run this and see how it works. What we can do is we can open two windows. So open a new incognito window. So that will be like two separate browsers with two separate sessions. We have a nice chat box. Okay, so we'll set the nickname over here as user1. Set nickname. Okay, so we received the nickname over here as well. Since we started the application, we are in the chat room, but we don't have a nickname. So what I mean by that is, if you look at the app.js, the incognito window, the user is connected, but the nickname is not set yet. Now let's set the nickname over here as well, user2. Perfect. So active users, we have two. Let's send a chat message, hello from user1, and chat message, okay, which is received instantly at both places. Hello from user2. I think there's a small bug. I pressed enter while I was typing the message, so we received this event of setting the nickname. Might be a small bug, but it doesn't crash the application. So let's proceed. So we have this working. Nice, simple. Now let's try and close the incognito window. User2 removed. So the disconnect event was fired as soon as I closed the window, but the messages remain. We're not doing anything to them. Great, we have this working. Nice. And you can see the console log messages that we have everywhere. Setting the nickname, the user list, so this is the array. Again, setting the second nickname, user2, we have the new updated user list. Chat sent by user1 at this timestamp. User1 saying hello from user1. So here is where I think I pressed enter and we got again, so this might be some small bug. Ignore this for now. User2 sending the chat at this timestamp, hello from user2. Okay, disconnect user2, I close the window. Updated users, we have the new user list only with one user. So very simple, but very effective, very powerful. So let's proceed. I want to track the location of the user. How should I implement it? In order to determine the location of the user, we need to determine the geographic location of the user's IP address. So to do that, we have a public IP npm module. We have the node IP locate module. So public IP is used to determine the IP address of the device, and then IP locate is used to determine the geographic location of the IP address. So it's a two-step process. And then node local storage is a web storage that allows JavaScript apps to store and access data in the browser with no expiration date. So one, to get the IP, second, to get the location of that IP, and then this to store it. Now determining the user location. So we import all the modules required, which we just talked about. Now, variable defined to store the city name of the user. So we have sets the value of the specified local storage item. So we have the IP locate and public IP. So when we receive a nickname, IP locate v4. So IP addresses are of two types, version 4 and version 6, IPv6 and IPv4. IPv6 is the new version of IP addresses, simply because we had IP version 4, the usual one that you have seen till now, like we write 127.0.0.1, or you might have seen 192.168.1 or 0 and dot 100, something like that. So basically the IP addresses where the range was 0 to 255 for each of the four numbers, those are the IP version 4. But since there are so billions of users now on the internet worldwide, again, it's a finite number. You can calculate how many IP addresses can be there in the world. So IPv6 was introduced, which is, again, devices I think use both. There's also, like, you get the both addresses. Not sure, maybe sometime in the future we might only have IPv6, no IPv4, but it's a slow progress. We can't just change things drastically on the internet like that. So public IP version 4 dot then, once the IP address is resolved, we get the IP address, we have the callback, then we use the IP locate, pass in the IP address that we received, and then once that promise is resolved, we have the callback function with the results. Results will have the city, which we will stringify the response and then store in the local storage, saying user local, something like that. Then what? Configure the HTML page to display the location. So sends location and payload to display the location in chat window, and then we append that. So we showed the list of all the messages in the text area with the first the timestamp and then the message. So we will also append the location over there. So let's see how this goes. So public IP, node IP locate and load local storage. Let's install and let's try and run these. Stop the server first. Let's import all of them in the app.js. Okay, now let's implement this. Let's console log the results so we will know what we are receiving. Also, let's console log the IP as well. Stringify the results.city and store it in the local storage. Now on the client side, also we need to send that in the payload. Okay. So what we need to do in this case is, since these are callbacks, so we have this callback once the IP address is resolved of the user. Then once the location is resolved, we have this callback. What we need to do is send the response over here. Since those are callbacks, if we send the chat response over here, then it might be the case that the chat is emitted first and then we get the IP location. So we don't want that. Also, what we will need to do is, so in the payload, we need to send the message, the nickname, and the location. In that case, we will just append the timestamp, location, nickname, and message. Send it like this. Timestamp over here. Now we have a city in the response, so I'll just say we can keep a pipe symbol over here, separate them. We have the nickname and then the message. So we'll have the timestamp, the response, the nickname, and the message will be emitted in the chat. Perfect. On the client side, when we receive the chat, let's look at the client side. When the chat is received, okay, so we just take the whole, so we're doing it a little differently from the what is shown in the slides. We're just sending a string, so we just have that data. It will just simply be appended into the chat box. So since these are callbacks, so whatever chat emitting you want to do, you should be doing it in. Also, since promises can be rejected as well, we should have a catch callback as well to catch the in case of rejection. So first I'll set this to be a variable. Now we don't have the location yet, so I'll keep it as it is. So this is the default one. We have the timestamp, we have the nickname, we have the message. Now all we need, one more thing, is the location, which we might get since these are promises. Depend on these external modules, the IP address, the location. In case they fail, so we need to keep this catch callback as well. So even in the catch, we are sending the response, so we are sending the chat. But then in this case, we won't have the location. We'll just have, so the chat will go on. We can also do a console log so we will know in case this callback was called. I'll say IP locate catch and say public IP catch. So now let's run the server, see how it goes. Port is listening. I should refresh this. Okay, let me copy this. The location, if we get it, should be same for both the users. I'll say user 1, perfect. User 2, perfect. Let's start the chat. Hello from user 1. Okay, Washington. Perfect. We have a location. Wow, nice. Hello from user 2. Perfect. We have Washington. In case you want to mock your location or you want some other location, what I would suggest is very simply use the Opera browser. In the Opera browser, so Opera browser again is very similar to Chrome, but as they have put in many more features and the UI is a little different. But if you open the private or the incognito window in Opera, in the private window you'll have an option for VPN just over here near the address bar. If you start the VPN, you will have a location, let's say from Singapore or somewhere from Europe. So in that case over there you'll have a new IP just for your browser. Nothing will change in your PC or in your OS level. Only for that particular browser it will have a new IP, a new location. So you can test it that way. So this is working perfectly fine. Perfect. Let's see what we got in the IP and in the location, what we got in the objects. So we got the IP 52. So this was the same IP for both the browsers. IP locate object gave us the IP address, the country, country code, city, Washington, continent, latitude, longitude, wow, time zone, postal code, okay, organization, I don't know what this is, okay, Virginia. Okay, so we got plenty of information which is really cool just from the IP. So this is working for us. I want to determine the number of active users present in the group chat. So, well, we are already keeping a list of the users in our array, but as you saw, in case we have a bug, that array might have duplicate values. So let's say we want to have the number of users at any given moment. The io.sockets.sockets will give the number of active connections. So number of active connections is basically the number of users we have. So whenever we have a new connection, we can simply get the list of all the active users using io.sockets.sockets. And then what object.keys does is, let's say you have an object with many key value pairs. Object.keys will take only the keys. So let's say you have an object saying x:1, so x value 1, y:2, y's value is 2, and z:3, z's value is 3, or Americans as they call it z. An object with 3 properties, x, y, and z. What object.keys would do is, when we pass in that object, will give us an array, and the array will have the values x, y, z. You will have all the keys of that object as an array. So pretty handy. The object named object with O capital, if you look at its documentation in the Mozilla's MDN website, the Mozilla Developer Network, it has a ton of methods that might be helpful, when you're playing with data, especially in the array objects and all. So it'll help you a lot. So let's see what we get in these io.sockets.sockets. So on connection, so let's try here, sockets.sockets. Let's console log this so we will know what we are dealing with. Let's restart the server and let's try again. So that console log of io.sockets.sockets should run when I open our application in a new window. This, if I see the console log, okay, we have a pretty big object. So let's try the object.keys. Let's see what we get in the object.keys. io.sockets.sockets. Yes. So the socket object is pretty big. Let's rerun the server. So we have like 2 IDs. Okay, so this might be what they are storing internally. So we have 2 users, so basically 2 connections, and these are like connection IDs. I refreshed, so maybe the IDs changed. Now we gotta emit the user list. And on the client side, okay, so this will just iterate over all the users and append them to the HTML page, the active users. Okay, so we are just sending these socket connection IDs, emitting them whenever we have a new nickname. Instead of users, what we will do is, I'll say ID list, because we already have the user object, ID list, and I'll emit an ID list as well. Okay, we're already maintaining a user list using this users. We're using an array. This will do it separately. Actually, you know what should be the case in properly? The users array should be like an array of objects where in the key we have the socket connection ID, and in the value we can store an object with user data, you know, like the user nickname or anything else that you want to store. Let's say even the location or the IP or anything like that. So we should have an object like that that has all the user info, the key being the connection, the socket connection ID kind of thing that we get, and in its value we should have a user object with the nickname or the username, the IP, the location, or XYZ, whatever. But okay, let's send this as well. So we have the user list. Okay, so now we have an ID list event. I think the L was capital. Yep, the L is capital. And when I receive that, so like the active user, we will need another box to store that. So we have the active users over here. Just create a new one. Active IDs, empty them. We'll name it socket ID. Okay, and there is this list 2. I'll say it ID list u. Where do we have this B tag? We're doing the same thing over. I don't know why we're doing it with the JavaScript first and then the jQuery. Doesn't matter. Setting it twice basically. Now, okay, we did this. Emitting on the nickname only. Okay, we should also remove them while on the disconnect, but okay, this is okay for demo purposes. So let's run that and see if we get the IDs as well. Okay, now we need to refresh the page to get the new HTML. Set the nickname. So we get both the socket IDs in one go because they were already there. So we get the socket IDs. They're just not fitting. We can adjust that with CSS. Perfect. So we're seeing the socket ID. We're seeing the username. Let's send a message. Enter. Message. Enter. Perfect. One last thing. Let's check. So we have this chat box. Okay, chat text. So what we can do is on the on key press event or on key down event, if the key is the enter key, we can send the chat as well. So that can be done. Simple thing, but let's see if we have anything remaining. Okay, so we got this. So they've named it user ID. We called it socket ID. It's okay. Fine. I hope you enjoyed this session. Thank you.